Thank you, Raymond, for the invitation to present as part of the Biomass to Biochar team. I am Jim Dooley, Chief Technology Officer at Forest Concepts in Auburn, Washington. We are a technology company that develops solutions and equipment that solve big deal problems across the biomass supply chain and the bioeconomy. This presentation is about one of the big deal issues that limits distributed and community scale production of biochar. There are a number of biochar equipment makers, but there has been little or no consideration of the need to maximize carbon yield or minimize the system-wide carbon footprint. Thus, we see yields as low as 5 to 15% of the potential carbon as stable biochar, and we see negative carbon footprints on the entire system due to emissions and energy consumption. The concept we are presenting today is to apply systems engineering to close the mass and energy balance for biochar production at moderate scales, while maximizing the yield of stable carbon. In this graphic, you can see that parts of the biochar production enterprise produce heat, while others, like drying, need heat. Drying produces large amounts of condensable water, while quenching at the outfeed of reactors needs water. Pyrolysis produces non-condensable gases that can be used either to fuel a dryer, power a generator, or provide heat to the front end of the pyrolyzer. As the conceptual graphic shows, it may be practical to approach net zero water, fuel, and grid electricity through a systems approach. The core unit operations to convert biomass to biochar are to grind or chip woody biomass into small particles that are amenable to conversion, to dry the material from 50 to 70% water down to 15% water, carbonize a dried milled feedstock using pyrolysis, gasification, or other oxygen-starved thermal processes, and finally to quench the biochar at the outlet with water to cool it and keep it from spontaneously igniting. As shown in the photo of the Amaron energy pyrolyzer on this site, since the conversion is not linked to other unit operations, the non-condensable gas is simply flared off. Our own company and others have designed relocatable dryers that dearly would love to use that gas instead of propane. If only we were co-located and had design coordination. There is a need for a team to provide coordination across manufacturers to characterize commercially available equipment for mass balance, energy, etc., and to encourage interconnectedness across suppliers. This sounds a bit like plug and play for software and hardware to those of you in the IT world. The same scheme would enable the biochar industry to dramatically reduce costs and risks for new enterprises across the landscape. If we do this well, not only will it enable distributed scale production with low cost and minimal technical risk, but it will provide data sets to quantify biochar products for carbon footprint, carbon sequestration benefits, and to provide uniform data sets for permitting. There are at least a handful of manufacturers, mostly entrepreneurial small firms, that make relocatable moderate scale biomass dryers, biochar reactors, gasifier generators, and other needed equipment. Thus, we do not need invention and high-risk development to capture these benefits. We need data, systems thinking, and coordination that can be provided by reporting, labeling, standards, modeling protocols, etc. When we are successful, more woody biomass from forest and suburban landscapes, utility corridor vegetation management, and wood waste can be converted to biochar. More importantly, this can be done at hundreds or thousands of community-based locations near biomass sources. Distributed production puts the jobs, economic activity, and utilization in the hands of local communities. Execution of this proposed project will require a large team of NGO, industry, academia, and lab participants. We need to create a framework for mass and energy documentation. We need to create a compelling reason for manufacturers across the system to join and participate. We need to apply modeling and systems engineering to define and specify biochar production throughput, needed adjustments to methods, and other things that are economically efficient and balance the mass and energy of the system from end to end. We are all tired of individual demos of machine X or Y out of context to the entire system. In this project, we will demonstrate the entire matched interconnected system with commercially produced units. We will run across seasons. We will produce enough biochar to make an impact in local markets. In the end, we will provide proof that such an enterprise can be sustainable and profitable. From a project management perspective, I personally believe that this should be led by a private entity or NGO, so it is perceived to be industry focused and not knowledge focused. As noted earlier, the equipment companies in this space are small, underfunded entrepreneurs or side sectors of larger manufacturers. Just as U.S. Department of Energy did with their high tonnage biomass to biofuels program, there is a need to fully fund the equipment used in this project. Similarly, we need to fully fund the community host and operators of the demo systems. The market for biochar itself is not proven nor lucrative at this point, so there cannot be an expectation of significant biochar sales to underwrite costs. The project management and advisory teams need to be broadly inclusive of stakeholders, regulators, finance firms, equipment leasing companies, and others. This is a big project, and we were challenged to define it within a 5-year timeline. This Gantt chart suggests that we can achieve meaningful results within the 5-year horizon. There is enough time for our manufacturing sub-awardees to adapt designs to the plug-and-play scheme and right-size their throughput. There is also enough time for a 12 to 18-month field demonstration. In the chart, it should be readily apparent management of Task 1 and Communications Task 6 span the entire time frame, but the heavy lifting is as shown. At this conceptual stage, without an actual proposal team in place, our working group would like to suggest that we could do a good job and achieve meaningful results with a budget of about $7 million over 5 years. About half of that will go to equipment manufacturers and our demonstration partners. In this presentation, I focused on one of the needs identified by our working group. This slide lists others that are critical to enabling biochar production at medium scale across the landscape. One of those is to monetize the carbon value of biochar. A second is to engage communities and others for integrated fuel reduction, forest management, and biochar production opportunities. You can see that this is a system within that larger system. Clear biochar product standards are needed to foster demand, and regulatory reform needs to enable broad distribution and location of facilities. With that, I would like to thank you for your time and attention. To follow up, you can contact me, Hans Apon, or Debbie Page Delmerose via email to set up a phone or web meeting. We would be happy to discuss this with you. Thank you.